So hello everyone, I am Oliver Hine. I have been a Clojure developer since 2012. And as I mentioned, most of that time I've been very fortunate to work with Juxt, who I think are probably known to all of you, on various different exciting projects. Worked with lots of great people along the way. And Martian is a library I started back in 2016, I think it was. If you remember back that far, that's when inflation was low and house prices were reasonable. And Corona was a kind of beer rather than something that ruins your life. And the genesis of Martian was when I was working for a bank's risk system. And the risk system is used to help traders track how much money they've made or lost, how much risk they're running, and risk comes in many different flavors. And all of these numbers have to be crunched and generated. And my team specifically, were working on a UI for traders to use, which gathered data from lots of different backend systems, all via HTTP. And it tried to materialize a view of the world that made sense to the trader, from which they could quickly see things that were generally fine and they didn't need to spend their attention on them, and to highlight things that looked odd, that didn't fit the expectations, so they could focus all their attention more usefully on that. And talking to all these different backend services, the shape of the data that we were moving around varied a lot. We had to use different IDs for different systems. We were trying to kind of stitch a graph together from all these disparate data sources, which was the logical view of the world, but the backend didn't necessarily represent it that way. The backend shaped things really according to the IT need for partitioning data, and the users weren't interested in that. They wanted their logical view of the world. And so all these HTTP services we were talking to meant that there was a lot of HTTP language in our code base, a lot of mention of hosts and ports and verbs and serialization and JSON and authentication tokens and logging and metrics and everything else. And all these things were leaking into our business code, which we didn't like. The business code was complicated enough, and we didn't need this extra layer of complication on top. But despite all that, we still love HTTP. It's simple to understand, I'd say. It's generally human readable. It's language agnostic, so it doesn't matter what language you use to write the service or the client. They all understand this kind of lingua franca of HTTP and the stuff we built on top. And web servers are easy to build and run. Every language has this as one of their simpler use cases. I love the Python one-line web server. And HTTP is broad enough to kind of do anything with, but it's also narrow enough that you can still reason about it. And the ecosystem around HTTP is very powerful. You've got browsers, JavaScript, libraries, loads of libraries, stable specifications that go through proper processes to change. And I think all that means that HTTP is, in nearly every case, the obvious choice to use for one system to talk to another. And it also, importantly, I think, decouples servers from clients so that you don't have a runtime dependency or a code dependency between them. And that helps you build simpler systems from smaller applications. But there are bad parts of HTTP, or not. No, I'm being very unfair. There are bad parts of what can happen to your code when you are dealing with HTTP. So for the next few slides, I'm going to be considering the classic pet store API example, where you can create pets and you can update pets and read the list of pets and delete pets. We won't go into all that detail, but here's an example of a function you might write to create a pet in your domain. And the contents of that function are very much HTTP domain, as we can see. So we've got stuff like the URL, which we're treating as a string. We know it's probably more complicated than that, but string concatenation gets you a long way. We know what the method is here. It's a post. We know that the species of the pet goes in the URL. This is knowledge that we've kind of scraped off the API. Maybe we've read some documentation. Maybe someone told us to do it this way. But we've put that in there. And if it ever changed, it would obviously break. We need to know that the age of the pet goes in the query params. Bit weird, but I'm doing an example here. We need to know that the request needs to be encoded. Sorry, the body needs to be encoded with JSON. And we hope that the server understands JSON as well. We need an extra bit of metadata in the header to say this is JSON. And here we also are expecting the response to also be in JSON. So we've asked our HTTP library to decode it as JSON for us. And at least this means we've hidden all this stuff away inside our create pet function. So that's okay. But as things evolve, sometimes even with the best intentions, some of this HTTP stuff might leak into the rest of our code base. I've made host and port part of the arguments to the function because maybe in non-prod, I talk to a different server. And this is now going over the network to another machine. And so there's the issue that we don't implicitly trust this other server, or it doesn't trust us. So we have to provide authorization. And again, because it's now a remote network request, on networks, things can be delayed or be dropped, or the other machine might be busy and can't respond to us in a certain amount of time, or some middleware is overloaded. So we had some timing to try and record that. And now, if we look at the signature of our function, we've got more non-functional arguments. There are 4 at the beginning. Then we actually have functional arguments. And this means that the number 1, that our HTTP-ness has leaked out. And number 2, that the signal to noise ratio here is quite low. The stuff that actually does something, the species and the name and the age, are kind of lost amongst the things that don't actually add functionality, just glue to make things work. If you have any experience writing server-side stuff, you may use many excellent libraries in the Clojure ecosystem, like Ring Swagger, that can make your handlers look something like this. And this is a more declarative way of signaling the arguments you expect your handler to be given. And it does a lot of heavy lifting behind the scenes so that you can destructure the parameters you care about, the name, the species, and the age, very simply, and be confident that they have been validated against your schema, meaning that your handler itself doesn't have to worry about any of the many code paths that should lead to things like 400 bad request or 401 not authenticated, because your middleware takes care of all of that, and it's working off a description of what your handler accepts before it lets your actual code handle a happy path. And this is kind of interesting to me because the client code that we just looked at making a request here kind of has a symmetrical understanding of this same idea. They both need to talk about the same thing for things to work. And we've made a copy in the client of all the things from here. So the method and the fact that age goes into query params and everything else is reflected in the client. So it's not dry. We've repeated ourselves. So there are technologies, most notably OpenAPI, which is previously known as Swagger, which can take a declarative description like this and turn it into a machine readable declaration that we should be able to use in other places to understand what this API is offering us. So at this point in the history of Martian, we had one or two Swagger APIs to work with, but our code on the client side didn't seem to take any advantage of that. We were using it as documentation that we could read, and then copying and encoding that into our own code base without really leveraging what it could do for us. So here is the human brain. It really makes you think, doesn't it? The business domain, as I mentioned before, was really complicated, and it took us a long time to learn. And especially when we had a new developer on the project, we wouldn't really expect much out of them for 6 months, maybe, for them to really get going, because there was just so much to learn. And when you have an environment like that, you need to make sure and try as hard as you can that you're not obscuring the intention of the code, which is often the best place, and usually the only place actually that you can go to try and understand the business logic, because we're not very good at formalizing our business logic and making it documented, at least in a way that's recent and kept up to date. And cognitive load theory calls all this extra stuff extraneous load. And it's really things that just get in your way. So understanding all those, what I keep referring to as HTTP-ness bits, are getting in your way of understanding what the system is really doing, which an example was creating a pet. So if you can remove that or reduce it, you can focus more of your time on the germane load, which is the actual business value stuff, the information that actually helps you deliver something to the business. So goals of the library, which at that point didn't exist, but I knew what I wanted it to do at that point, which was hide HTTP-ness from the point of call. When I create a pet, I want to give the name and the age and the species, and everything else should just be handled by the machine. Why not? It's doing machiney things. The machine should be able to do it for me. And I wanted it to understand OpenAPI because that was the best example at the time of describing what an API could do. And it should work well out of the box, but I wanted it to be extensible, support custom behavior. We already had many examples of systems that we talked to that had some quirk of some sort or other, like a different way of authenticating, or a weird serialization format or something like that. So we needed to be able to plug that in. These are goals for Martian, by the way. I do have a personal goal of, for the last 3 years, of running a marathon, but that's become a running joke now. So, in a nutshell, Martian uses description of HTTP APIs, and it provides a simple and functional interface that's agnostic of HTTP. And it's important to distinguish here what you can do with an API, which is functionality, and how you invoke it, which could be HTTP, but could be other ways of expressing an API, like a client library or a database driver or something more esoteric. And even when you are talking about HTTP, there are flavors. You can use HTTP itself, the bare bones, URLs, methods, headers, that sort of stuff. But there are other implementations that kind of sit on top and use HTTP as a transport almost. Things like GraphQL is an interesting one, especially as it's self-documenting, and SOAP as well. A fun fact, I used to be addicted to soap, but I'm clean now. And regardless of how many ways your API can be called, the functionality remains the same. If I have a client library and a REST API and a GraphQL API, all for the same thing, the functionality would be the same, but we're just addressing it in a different way. So here is the one-liner, the hard sell. And you must be impressed that I've got the nerve to call this a one-liner when I even have line numbers going up to 5. So here I'm instantiating a Martian. It's using the Bootstrap OpenAPI function, and I'm pointing it at some API's swagger.json, which is describing what the API can do, but also how it does it to me. And that's pretty much all the HTTP-ness that you should see is this one URL. And it's left me with a functional Martian thing that I can call functional things on, like create a pet. And I give it the parameters of the name and the species and the age. And it does all the rest for me. It builds the URL, it chooses the right method, it puts the parameters in the right place in the URL or the query or the body. It chooses the best encoding that the server supports, that Martian also supports, and uses that. It will decode the response on the way back. And so my return value from this response for create pet would be just data, just the data that came back from the server. And this has done all the mapping of the HTTP domain for me, and it's left me with just the mapping of the business domain around pets. And this is reducing that cognitive load, that extraneous load, and it's kept my code concise. It stopped everything leaking into it. And because I have one Martian with which I may call many endpoints on this API, it keeps them all consistent. So I don't have typos or miss things out in some endpoints that I don't in others. And that's very important, I think, for things like metrics and logging and other cross-cutting concerns. And I think, interestingly, for this one, it actually allows a small amount of refactoring on the server without this code actually breaking. So if you were to, I say refactoring of the HTTP part of the server. So if they were to shift all the URLs to have an extra prefix, if they were to move the query params out into the body or something like that, all those things would actually carry on working. The post could be changed to a put, and my code here would carry on working. So I think that's pretty cool. And in case I've lost half of you already because you think, oh, I don't have any open APIs to work with, then you don't need to worry, because you can describe the APIs yourself in your own code. So here is the concise mapping of someone else's API, all the HTTP-ness of it, in a declarative way that Martian understands. And this gives you the same effect, but you do lose one benefit, which is that if the remote API changes, then this could drift from it. And that is a reasonable downside, but you get all the other benefits still of your concise code. Martian itself is implemented using a library called originally Prismatic Schema, which I think is now Plumatic Schema for legal reasons or something. It's an old library, but it's still a really good one. And it can take care of things like simple coercion for you. It can throw errors when you have bad data. It's a validation. And in this example here, I've left out the species, and it's given me a nice human readable error message on the client side saying species is missing, but it's a required key. And the request never got made to the server here. It's validated it on the client side before it sent the request and said, this is not going to work. You're missing a required key. And the reason that's important is because I can give a nice error message on the client side. If we'd allowed this to go to the server may have just blown up and given a 500, and we would possibly be none the wiser why it was unhappy with us. Or produce some huge stack trace, 3 megabytes long, which also wouldn't be very helpful. So I think this is a nice feature to have. And what you may also have noticed is that the age here is a string, but it's not complaining about that. And that's because simple coercion from a string to a number is also handled. And it just eases the way data flows through your system, I think. Obviously, it's not nice that a number became a string at some point, but when we're talking in general about lowering impedance between components of a system, I think this is a nice feature to have. You can turn it off, of course, if you don't like it. So now I'm going to talk a bit about interceptors, as I mentioned before. So Martian itself is implemented almost entirely as interceptors, and all those interceptors are code that you can use and see. So if you are familiar with Pedestal, which I think was where the idea originated, or certainly was implemented in a way that many people came into contact with it, or Reframe, the front-end library, uses this concept too. An interceptor is a very concise and single-purpose piece of code that takes a context and augments it, and then sends it on its way to the next interceptor, and so on, until you reach the end of the chain. And it's very simple, which is great, but you get this full power of composition that I talked about earlier, being one of my favorite things. And they can all work together in a chain to build up a request. When I say request here, if you have in your mind this idea of a ring spec library for a request, which is fortunately is a great spec. I think it's really helped simplify the Clojure ecosystem around HTTP, and nearly all the HTTP libraries and server libraries implement this spec, which is great. It means all these interceptors can be reused, regardless of which library you're using. And so the first interceptor might say, my job is to build the URL to use. And another interceptor might be in charge of setting your query params, and another for encoding the body. And then the one at the end of the chain is for performing the request, the actual request that we've now built up. So at that point, we will call into an actual HTTP library, and that will call the internet or wherever it's going, and return a response. And the response is then put back into the interceptor chain, but now we're popping things off the stack, and we're going down the leave phase and running interceptors on the way out, which might be something like decoding the body. And the important thing about interceptors, it's really just a vector of these interceptors, a vector of functions essentially, which means that you can look at it and reorder it even, and add some and remove some. And that's where its power really lies. So we could have a quick look. That's an example here. One moment. An example of injecting an authentication token into all the requests we make. So here's our secret password. And I usually use my cat's name as a password, but I keep getting hacked. So I've had to rename the cat 3 times. But your own interceptors, they might be for authentication, they might be for logging, for metrics, stuff like that. They're the ones that you commonly want to add, which are cross-cutting concerns. And I personally believe that an interceptor is the best way of exposing your library to the user to be able to extend and enhance and change. It's let Martian stay, I think, true to its goal of being an abstraction from HTTP and not having to support every possible use case that people might have. just because they want to hide stuff. You know, if they want to, they can write their own interceptor to do something, stick it in the chain, and the library stays small. So here what we're doing is we're giving an enter function. It's taking the context. The context is building up a map, a request map. So we're just sticking in an authorization header here of our secret token. And then we take that whole interceptor and we stick it in the chain. This is the same chain I had before, but the blue ones are now ones that I've added on my side outside the library. So I've got the authenticate one there at the bottom at the end of the interface. And that means that the token is there when I come to perform the request. And as an example, I've shown on the leave phase that maybe I want to add another one called log errors at the end of everything. So that if something went wrong, I can log it in my application logging. And that will be done consistently across every request I make on all the endpoints that use this instance of Martian. The dotted line shows that you can just plug in anything wherever you want. And logging is actually a funny one because there are, despite Clojure being generally good about having maybe just a handful of libraries for everything you could want, so that you know, there's not so much choice that you're paralyzed, but it's not like there's only one choice and you feel like you're lacking options. But logging is sadly one where I think we've inherited this from Java, but it's really quite a mess. And so when you're writing a library for other people to use, it's actually quite difficult to work out what logging library or framework should I be using in my library so that people using it can easily plug it in. And I think the lowest common denominator is probably is Java util logging, but that then may limit you to doing other things. So if I can expose the cool stack of Martian, just say, look, you can stick a logging interceptor any way you want, then I get to avoid that decision altogether in my library, and logging is your choice. So yes, interceptors in general, they're great. They let each interceptor is kind of a single purpose, decomplected, and then the behavior is composed together overall, which I think is the ideal that we've all come to value and believe in the Clojure world. So I'll talk a bit about testing now, because I guess as soon as you write a library that tries to hide some stuff away from you, you may then have the problem of, well, how do I test it if it's hidden it all away? And the old way of doing things, I'd say, is you write a mock. We've probably all done it. And the mock is normally just good enough for you to write your test. But unfortunately, you will find with your mock that it will drift away from what the real API can do. And your test will use that mock, but if the mock doesn't do what the real API does anymore, then you're actually testing that you're doing the wrong thing. And mocks can be hard and time consuming to write, depending on how complicated the API is. And you may have wasted a lot of effort, as well as just being wrong. And you may find again that HTTPness kind of makes its way back into your code. This time it'll be in your test code. You'll have some code to set up a mock, and it'll be full of URL routing and query params and verbs again, which you don't really want to see. That equally obscures the purpose of your test in the same way that our source code was obscured as well. So we don't want that. So Martian has its own answer. It's got a submodule called Martian test to help you keep your code testable. And it uses many of the features that that Martian has as its core to help your tests. So even if you don't use the Martian test library, the feature that validates your requests before they go out can help you. So if you're exercising some code with a test and it makes a request which doesn't fit this remotes API description, it will throw that error that we saw earlier, that you're missing species or something. But if you do use the Martian test library, then you get something that can actually return responses in a way that hides the HTTP-ness again. So you can say, my Martian test expectation is that this endpoint, the create pet endpoint, for example, returns a body that says, your ID for your created pet is 123. And you don't have to do any of the fiddling around with the URLs or the verbs or anything, because they are now addressed by that ID of the endpoint, which is create pet. And it hides it all away again. And because we know from our server declaration all the possible values it can return, because that can be described by a schema as well, we can even use it for generative testing and say, for every request I may make, generate a response, and we'll see if my response handling code knows how to deal with it. And another sub module of Martian is called VCR. And for young people out there who don't know what a VCR is, it's like a mini disc player, but for your TV. But don't confuse it with Betamax. So, well, now you know. But really, it's just an interceptor. Everything in Martian is an interceptor. This is just one more interceptor that replaces the one. Sorry, it doesn't replace the one. Martian test replaces the one that makes the real request. The VCR sits just before and just after the one that makes the real request, and it records the outgoing request and the incoming response onto disk. And then you can use it to play back the interaction between your application and the server. And this can be quite useful for functional tests, but also for things like load testing or even just data analysis. Of having essentially will build you a fully functional stub based on the behavior of application. And if you're not sold yet, that might be because you're thinking, well, Martian will probably tie me into one of these HTTP libraries, and maybe I don't want to use that. But the answer is no. Martian supports all 7 of these HTTP libraries. And again, because they all support this ring spec, that's made it very easy. But even if they didn't, this is just the final interceptor in the chain to actually call out to the HTTP library. And so all of these have been implemented over the years as they sort of came into existence. So there are 7 of them now. This list is more impressive than my local library, because that's just a one-story building. In a project that the project actually started in Martian. We did start off using CLJ HTTP, which is solid, but we did want something a bit faster because we had a few million requests to make. So we tried HTTP Kit, and I think that was faster, but it was not very good at SSL. So that made it a bit painful to use. And so later we moved to Hato, which is much closer to the metal on JDK 11 and upwards. And that made things a lot simpler, and SSL was much better. But we were fortunately able to make those 3 changes of HTTP library without really changing our production code at all, which is very nice. So I think in many ways that validated the original approach to Martian, which I was very pleased about. Now, Martian has now, at its age of 7 or 8 years old, it's had code contributions from 24 amazing people, of which, of course, I am one. So we've had new HTTP libraries like Babashka most recently. Someone else added support for OpenAPI v3. And this is very important, really, because over the years, my projects and my roles and my teams have changed, and I haven't always had time for open source always been less time than I'd wish. And so it's been great that, lots of other people have helped, and, made it better for everyone. I'm really grateful for that. And I hope that one of the reasons that made it easy for people to contribute was that Martian itself was as small and simple as I could make it. Has plenty of tests so that people feel confident in making changes. I always tried to make the README as understandable and clear as I could, and I hope that has helped people to contribute, because it's certainly made my life easier for it to keep ticking along with help from many other people. I was going to tell a time travel joke here, but you guys didn't like it, so I won't. The library is stable now. Has been stable for a while, but we still get ideas and requests trickling in. One interesting one, I suppose, that I haven't done, an idea I have is really because I think Plumatic schema is, like I said, it's old, but it's good. And if anything were to supersede it now, I think it would be a bit of a tie between Clojure spec and Mali. And in a way, I think that's a bit of a shame, because in the days of Plumatic schema, everyone used that and it was great. And I think we've got a bit of a schism now where some people have gone the Clojure spec route and some have gone down the Mali route. And it means that maybe if I were to have to choose one of them, then I'd leave some other people unhappy. But equally, Plumatic schema is kind of end of life. So I could try and make that pluggable, but I think that would be a fair amount of work. And at the moment, there seems no great demand, so I'm going to keep that on the shelf for now. I think even just looking around the internet these days, not many APIs seem to actually have an open API description still. So, as people come to adopt that a bit more, I think it certainly got a lot more powerful with the move from V2 to V3. There's perhaps some more growth there as these things become more commonplace and people want to use them more. And even if Martian the library doesn't change much anymore, I still love the idea, the core idea of reducing cognitive load where I can. And I will definitely be using interceptors again in any libraries that I write, because I think it's probably the best way of reducing the burden on me as the maintainer by leaving it open for people to play with and adapt to their own needs, rather than needing to ask for a change or for everyone having to agree to that change that uses it. So my last thoughts, you'll be pleased to hear, for you to think about as well, are to look at the projects you work on and the libraries you work with, and just take a bit of time to consider what is germane knowledge and what is extraneous, and make efforts to reduce that extraneous load, because it's just getting in your way. And there are things in there that are important that you should be spending more effort on. I think libraries should help improve your test code as well as just your production code. And can there really be a better way of letting someone adapt your library than just giving them the whole call stack as code? I don't think so. But you may disagree. Thank you very much. I think that's everything I have. Be interested to hear any questions you've got.